Student was asked to answer the following. For these complex numbers, z1 and z2, find the value of the argument of z1 over z2. The student's attempt is shown and they've made errors in line 1 and 3 and were asked to correct them. So a good idea is to just sketch out the complex numbers. Z1, 3 minus 3i is going to be sort of down here. And as you can see immediately that, well, actually, I'm going to go with it being this. I go between 0 and 2 pi normally. Yeah, it's not going to be pi over 4, because pi over 4 would be up here if it was 3 plus 3i. So they should have done put a minus in there. So arg z1 is actually, inverse tan of minus 3 over 3. This ends up being minus pi over 4. Now remember, when you do this, you actually get the same, you also get minus pi over 4 here. So in that case, you would add on pi, but for me, I'm going to be adding on 2 pi. So that's going to give me 7 pi over 4. Then for part 2, line 3. Well, line 2 is okay. Line 3, they've done the argument of z1 over z2 is argument of z1 divided by the argument of z2, but actually you subtract. And that's what we need to state here. So when you're doing this in first year, you can use addition formulae and trig to prove that. Now we're in second year, we can use the polar form because z1 over z2 would be r1 e to the I theta 1 over r2 e to the I theta 2. And that becomes r1 over r2 and then e to the I theta 1 minus theta 2. So you can see, even when we're dividing the complex numbers, we subtract the arguments. We're then finally asked to write down the correct value of the argument. So we've got, remember, it's argument of z1, which we've worked out is 7 pi over 4, minus the argument of z2, then we're minusing pi over 6, and to be honest, just put that in your calculator, you're going to get 19 pi over 12.